Let's take a look at what compound formulas are. Compound formulas include several conditional aggregate formulas and may also contain horizontal expressions. In this case, each expression can be an aggregate formula or a horizontal formula. If all the expressions included are horizontal formulas, then the defined formula is not compound but horizontal. Conditions are any valid logical expression and may contain attributes belonging to the extended table of the table associated with the attribute being defined as a formula, constants, functions, logical operators, and or not, and relational operators. More than or equal to, less than or equal to, not equal to, and like. The first condition that evaluates to true will cause the result of the formula to be that of the expression to the left of that condition. The others will not continue to be evaluated. When none of the conditions evaluated are true, if there's an expression with an otherwise clause, the result of the formula will be that of the expression preceding this clause. Let's see an example of this type of compound formula in our travel agency reality. Here we see that the flight occupancy attribute was defined based on horizontal expressions that assign the corresponding value of the occupancy domain, low, medium, or high, depending on the number of seats on the flight, which are calculated with aggregate count formulas. In particular, in our case, we could have replaced the aggregate formulas with the flight capacity attribute, but it's perfectly valid to leave it as it's defined. In this implementation, the structure is that of a horizontal formula, and the aggregate ones were included in the triggering conditions. In this example, we want to calculate the average number of passengers that traveled on a given flight. Remember that unlike the flight transaction, where we define flights in a generic way, in the flight instance transaction, we model the actual instances of a particular flight, with a date, flight number of passengers, and so on. To calculate the average number of passengers that took each flight, we must add the total number of passengers for all instances of that flight, and divide it by the number of flight instances. We define the flight average number of passengers attribute in the flight transaction as a global formula, calculated as the quotient of an aggregate sum formula, which adds the flight instance number of passengers attribute and divides the result by the number of instances of the flight, calculated as an aggregate count formula that uses the flight instance date attribute to count all the instances. Note that since the formula has been defined as global in the flight transaction, its context is the table associated with the formula attribute, in other words, the flight table. Therefore, the result will be the average number of passengers of the instances of the particular flight in which you're positioned. Also remember that we have the aggregate average formula, with which we could have done this calculation, but we did it this way to prove that it's possible to compose formulas to create compound formulas. And we could continue to compose calculations. For example, if we were interested in the average revenue per flight, we could have multiplied the average number of passengers by the final price of the flight final price attribute. Note that this attribute is in turn a horizontal formula, so GeneXus can easily perform complex calculations such as the ones described. Compound formulas provide great flexibility for defining calculations and make it possible to model a large number of situations. In this video, we saw how convenient it is to use formulas to save code, taking advantage of the simplicity of declarative programming.